In this video, we're going to talk about finding the difference quotient. All right, and the difference quotient just gives you the rate of change of a function at some instantaneous point. That's also known as a derivative. When we talk about this word rate of change, literally what we're talking about is what we call our slope. And if you don't know this, the slope is found by taking 2 points on a line and calculating their rise over their run. So we can have a point here and a point here. This original point is what we'll call x. And the y value for x is what we're going to call f of x. Then we have a point here that we're going to move over by h. So this just becomes x plus h, and then the y value is now going to be f of whatever x plus h is. If we want to find the slope, then the slope is simply equal to y2 minus y1 over x2 minus x1. In this particular case, our point here is the x2, y2, or x2, y2, and this point right here is our original x1, y1. Now, if I'm using function notation, though, we call this y1 f of x. And if I use this new notation right here, we're calling this y2 f of x plus h. So replacing that gives me the difference quotient. And it's called the difference quotient because the slope is simply a quotient. But we do our y values, which in this case are equal to f of x plus h, or that's y2, minus f of x, that's y1, over x2, which in this case is just some x value, or x plus h, minus the original x value, which is here. Notice in the bottom of this problem, you have an x, positive x, and a negative x. They're going to cancel. So we get our difference quotient to be this formula here. F of x plus h minus f of x divided by h. And so all we're doing now is we're going to use this right here, this function right here. For every x that we see, we're going to plug in the original f of x function. And the first part of the function always tags a h along with it. So when we write this out, here's how we're going to start it. We're going to plug in x plus h for every x value here to start it. So we have this then. We have 3 times x plus h minus 5. And then we do the next part, which is minus f of x. Well, that's the original function, which is just 3x minus 5. I'm going to divide this by h. Now, notice here you have this 3 sitting in the front, so we'll distribute this 3 here and distribute here. And we get this 3x plus 3h. And we have minus 5. And again, I should have put parentheses up here. So we see this. This is the f of x part. And notice you have a negative sitting in front of that. So we'll distribute this and distribute that. And from there, we get the minus 3x plus 5. All of that divided by h. So here, because of the way our signs work, notice the 3x is cancel. Negative 5 and positive 5 cancel. And you're left with just a 3h over h. So in this particular problem, here's what should always happen in the difference quotient. Things should always cancel. And you're left with some term with an h in it. And when you finally cancel this out, notice you have an h on top, h on bottom. We get a difference quotient of just 3. So look at the next one. This time our original function is 2x squared minus 3. So again, same concept. Every place I see a x in, to start with, I'm going to plug in x plus h. So here I have 2 times, and the function I'm plugging in again is x plus h And I'm going to square this, minus 3, minus. And now again, I write the original function, which is just 2x squared minus 3. I'm going to divide all of that by h. So now we have to do some math here and clean things up. So I have a 2 times x plus h squared is really just x plus h times x plus h. That's what x plus h squared means. When I distribute everything out, I get x squared plus xh plus xh again plus h squared. So if you clean that up, here's what you get. You get x squared plus 2xh plus h squared minus 3. And then again, you're going to distribute this negative to both these signs here. So you're going to get a minus 2x squared plus a positive 3. And you're going to divide all this by h. So we have this 2 thing in the front, so we need to distribute it here, here, and here. So there I get 2x squared plus 4xh plus 2h squared minus 3 minus 2x squared plus 3. All of that divided by h again. And remember, things should start to cancel at this point. So we have 2x squared canceling. We have positive 3, negative 3 canceling. And the only terms I have left all involve in h. So we have 4xh plus 2h squared. All of that divided by h. Here's what's special about this now. Notice at the top, both these terms have an h. We can factor here. So when we factor, we're going to pull the h out of each term. So I'll put the h in the front, and I'll rewrite the term like this. 4x plus, you have 2 h's because h squared is h times h. So I have 2 h's. So when I pull one out, I'll be left with one left. So that's 4x plus 2h. And I'm going to divide all of that by h. The reason that I need to do that factoring is because here's what's going to happen. The h in the front here will cancel with the h down here. And here's the actual difference quotient, which is 4x plus 2h.